Let's talk concentration. Listen, concentration is very widely used in chemistry, biochemistry, and any other type of science because it's the best way to quantify a chemical, especially chemicals in solutions. Right? I have a drink right here, and if I have a drink, how do we know the amount of sugar in this drink? Well, concentration, right? It's the amount of sugar in a certain volumes, and that's what concentration is. Concentration is the amount of your solute out of your solution. So if we've added, for example, 10 grams of salt in 100 milliliters of water, right? The concentration will be, well, how much that is. And we'll talk more about that, but I want to emphasize that it's important in food, it's important in drugs, for example, in the hospital. Dosage is really, really important. And that's why we study concentration. So here, let's see, as you can see, these two graphs right here. If I add a little bit of salt in water, we've made a solution, right? Salt is a solute, water is a solvent, we made a solution. If you add a lot of salt, now it's more concentrated, right? It's more concentrated. That's why we say the concentration is the amount of solute dissolved in a given amount of solution. We add more solute, we increase the concentration. All right, so that's what concentration is. But the main thing that we're going to look at here is different formulas based on concentrations. So the overall formula of concentration is the amount of solute over the amount of solution. But we're going to have, depending on what we're measuring, we're going to have different units for the solute and different units for the solution. And that is where different formulas for concentration come from. They come from different versions. And it's important to know that because it depends on what we're measuring, right? So imagine like if I'm measuring the amount of sugar in my cup, I can use the grams for sugar and then I can use the milliliters for the water. But what if I'm measuring the amount of mercury in the river? The river is huge, right? And mercury will be very small. So we're going to need to use a different unit. It's still the same idea, but we just need to use the different units. Sometimes we're going to multiply by 1,000 or 100 or whatever. But this is the general formula. The concentration is still follows this general formula. So we're going to be starting to look at a few formulas for concentration, and the first one is the weight per volume percent. This is the one that I was just talking about in my example, where you take the grams of solute over your milliliters of solution times 100. The grams of solute over the milliliters of solution times 100. That's weight per volume percent, and it's expressed by percentage. Right, so let's look at an example. We prepare the solution, and to be able to answer these questions, it's important to follow the general rules for answering these problems, which is first you identify what's being asked and what they're giving you, and then second, you look at what you have and you figure out an equation that can connect the two. Number three, you might have to rearrange the equation to solve for what they're asking. And number four, you just plug in the numbers. So let's practice here. It says a solution is prepared by dissolving 25 grams or KCl in water to make 50 ml solution. So which one? So if you dissolved KCl in water, which one is your solute? It's KCl. Which one is your solvent? It's water. And the solution is the whole thing. So here, what did they give us? They gave us the grams of solute, which is equal to 25 grams. And then they gave us the ml of solution, which is 50 ml. And then what they're asking is percent per volume. So it's like weight per volume percent. That's what they're asking. And this one is easy. After you wrote down everything that you have, you're going to look at the formula. Which formula do we use? They told us we use weight per volume percent, which is equal to the grams of the solute over the milliliters of the solution times 100, right? That's what you need. And I don't think, usually now step 3 is moving around our formula, but we don't have to do that. We just say weight per volume percent is equal to grams of solute, which is 25 grams, over the milliliters. So here, this is the milliliters of the solution, which is 50 ml times 100. And this will be 50%. See what we just did? We just plugged in the formula, right? Nothing serious here. Now, I can ask you one of the terms. So when I give you a formula like this, it doesn't mean that I'm always going to give you to ask you the weight per volume, right? I'm not always going to ask you the weight per volume. I can ask you the grams of solute or the milliliters of solution. And you're just going to have to know how to move the formula around in order to find it, right? And it shouldn't be too difficult. Let's look at an example. Calculate the mass. So, right off the bat, they're telling us what they want us to calculate. So let's just write down, follow the steps. So the mass, they're asking us the mass of KNO3 in 500 milliliters of 2.5 weight per volume solution. So you know that KNO3 is your solute. So what they're asking is the grams of solute. And then they gave us the milliliters of the solution, which is 500 milliliters. And then they gave us the concentration, which is weight per volume percent in this case, which is 2.5%, right? So they gave us this, they're asking for the grams of solute. So step 2, find the formula. So we use the same formula, weight per volume percent is equal to the grams of solute over the milliliters of the solution times 100. All right, now here comes the tricky part. Step 3 is you gotta move your formula around to solve for what they're asking. And some people find this pretty tough. But really, all you gotta do is remember that we do the cross multiplication, right? you do your normal cross multiplication like this, right? And this is where a lot of people get it wrong. They don't know where to put 100. So here, this would result in weight per volume percent times ml of the solution is equal to grams of solute times 100. 100 is at the top, so it's equal to grams of solute times 100. All right, that's the hard part, the cross multiplication. After you did that, you're good. So now all you need to do is solve for what we need. What do we need? We need the grams of solute. How do we solve for the grams of solute? When you have something like this, you divide both sides by what's next to the grams of solute. So here we divide by 100, and we do that so that they can cancel out and you have grams of solute by itself. So in the end, you say grams of solute is equal to weight per volume percent times ml of the solution over 100. Look at that. We got the formula for what we need. That's step 3. Step 4, all you need to do is just substitute. So grams of solute is equal to weight per volume percent, which is 2.5% in this case, times ml of the solution, which is 500 ml, over 100, and that is 12.5 grams. Look at that. So again, emphasis on, you need to be able to do the cross multiplication and figure out one of the terms from your formula, and that should be okay. All right, so that's weight per volume percent. Sometimes you're gonna have weight per weight percent, and the only difference is that we're going to have grams of solute over grams of solution times 100. So instead of milliliters of solution, it's grams of solution times 100, right? And that should be fine. You should still be able to do it, no problem. And again, sometimes with this one, instead of asking you the weight per weight percent, I might ask you the grams of solute, and you just need to know how to move it around. And how do we move it around? Same thing we just did the other one. We do the cross where you say that percent of weight per weight is equal percent weight by weight times grams of solution is equal to grams of solute times 100. And then from here, you can go ahead and solve out any of these 4 terms depending on what I'm asking you. So you should be able to move it around like that. All right, so let's go to the next one. The next one is still the same thing. So let me explain why we need these next ones. You have weight per weight percent, which is okay, but if you have something that's very, very small, so if the solute is really small and the solution is really, really big, like I was saying, maybe the grams of mercury in a whole river or in a whole lake, even if you take this really small number over this really big number times 100, the weight per weight percent is still going to be 0.000000000 something. So it's going to be almost nothing. That's why we need to multiply by a number bigger than 100. So we have PPT, which is parts per thousand, and then you have ppm, which is parts per million. It's still the same thing. We're just multiplying here by 1,000, and here we're multiplying by a million, right? And instead of multiplying by 100, see the difference? Weight by weight, percent is by 100, PPT is by 1,000, ppm is by a million. And ppm and ppt are the most often used for the very dilute solutions because, we're multiplying them. So you hear ppm a lot when we're talking about, for example, climate change, when we're talking about the concentration of CO2 in the air, for example, we use ppm. So we're going to use these, but it's still the same idea. And because it's still the same idea, guys, you have to remember to do this. So let's say I ask you something about ppm. So ppm is parts per million. ppm is equal to the grams of solute over the grams of solution times a million. ppm, parts per million, right? This is good. So if I ask you for ppm, you just take the grams of solute over grams of solution times a million. What if I ask you for the grams of solute? Well, cross multiplication, that gives us ppm times the grams of solution is equal to the grams of solute times 10 to the 6, right? That's the cross multiplication. And then from there, you can solve for grams of solute by dividing both sides by what's next to grams of solute. In this case, is 10 to the 6, 10 to the 6. And what happens is this cancels out like this, and then the grams of solute are equal to ppm times the grams of solution over 10 to the 6, right? I really want everybody to be able to do that. And if you can't, you can just go ahead and slow this video down, go back, replay it. And I also have a video where I talk about basic algebra on how to do this. So if you struggle with this, check out my other video. But everybody needs to be able to do that. So we just looked at a few concentration units. We looked at, we looked at weight by weight percent. We looked at weight by volume percent. We looked at PPT, parts per thousand, and parts per million, right? These are good. These are good. We like these. We use them. But in chemistry, we use moles a lot, right? You can use grams. If you got grams, you can go from grams to moles, right? And we know that moles are more accurate because these are really the quantity that is in your solution. So we have a lot of mole-based concentrations. But before I introduce these, it's two of them. One is called molarity. I noticed that both of them has mole in them. The other one is molarity. It's two of them, right? They are similar but a little bit different, and we'll talk about how in a minute. But before that, I really want to emphasize that we need to know how to go from moles to grams. So you have moles to grams. How do we go from moles to grams, right? And grams is mass. You do that by using this little formula. If I give you grams or mass to find the moles, you say moles is equal to the mass over molecular weight. And then if we're going this way, if we want the mass is going to be equal to just cross multiplication of this. N is going to be equal to N times MW, right? So from now on, I want you to remember that if you have the mass, you can find the moles. If you have the moles, you can find the mass of any compound or any chemical. All you need is a periodic table to find the molecular weight. A lot of students get to a point where they need to find the mass and they're like, where do I find the mass? There's no mass in this equation. If you have the moles, that's okay, you can find the mass. Same thing goes the other way. If you have the mass, you can find the moles, right? So I'm saying this because we see it in the next section a lot, because the next section we're going to talk about concentration terms that use moles. So here, this is our equation. So we have 6 equations of concentration. So 6 different equations of concentration that you're going to need to know. So we've already looked at these 4, and let's look at the next 2. So the first one is molarity. Molarity is really important because this is the most used concentration measure in the lab and in science, right? We love molarity. And what is molarity? It's just moles over liters. Moles over liters. Let me give you a quicker way that I like to write down the formula for molarity. It's M is equal to N over V. This is much easier. As long as you remember that your N is in moles and V is in liters, right? This is molarity, right? It's the number of moles per liter of a solution, right? And we symbolize it by M. So if I have, for example, a molarity of 2, I will write 2M. And how do we read this? 2 molar. We say 2 molar. And 2 molar, what molar means, it really means mole per liter, right? Molar means mole per liter because the molarity is equal to moles over liters of solution, right? So one thing to remember is, let me see if I can set it up correctly. Okay, so molarity is equal to moles per liter, right? N over V. This V is in liters, and this N is in moles, right? Now, the reason why I'm doing this, I'm saying that remember that if you don't have moles, you can get the moles by taking the mass of them over the molecular weight, right? And another thing too is here, the liters, sometimes you won't have liters because a lot of times in the lab, a lot of beakers and cylinders and stuff like that, they will have milliliters instead. So you will need to convert from liters to milliliters. Just remember that 1 liter is equal to 1,000 milliliters. So to go to liters, it's just whatever you have over 1,000. whatever milliliters you have over 1,000. So these two things are the ones that trick people when it comes to calculating. So let's look at an example. Calculate the molarity of a 2-liter solution containing 5 mole. This one is easy, right? I just gave you the moles, and then I gave you the liters, and then I asked you what's the concentration. Well, the concentration, the molarity is moles over liters. So all you have to do is just substitute, right? Moles over liters, 5 moles over 2 liters, 2.5 molar, 2.5 molar. Remember that. So, and remember my simplified version of the formula, which is M is equal to N over V in liters, right? But this is an example. Another example is something like this. I can give you, instead of giving you the moles, look at what I gave you. I gave you the grams, right? So, and we have glucose. So the mass of glucose is equal to 5 grams. And they gave us the volume of the solution, which is 1 times 10 to the second milliliters. So this is the volume, which is 100 ml. And then they're asking the molarity. All right, so that's step 1. Step 2, let's find the formula. The molarity that they're asking is equal to N over V, right? N over V in liters. That's okay. That's okay. We do have V. It's just not in liters. So let's convert this into liters real quick. This is equal to 100 ml over 1,000. So it's 0.1 liters. No problem. So you have the volume, but you don't have N. How do we find N? Well, guess what? You have the mass. So N is equal to mass over molecular weight. No problem. So you find N, and then after you find N, you find M. So for that, we need the molecular weight. The molecular weight of glucose, again, you can find this on the periodic table. I believe it's 180 grams, right? That's the molecular weight of glucose. So all we have to do now is just substitute by starting by N. N is equal to mass over molecular weight. This is equal to 5 grams over 180 grams per mole. That's the molecular weight. So 5 over 180 is equal to 0.027. This is the number of moles. And after you get the moles, now we're ready to find the molarity. It's the moles over the volume in liters, which is 0.1 liters. This is going to be equal to 0.27 molar. All right. So this is an example where they want the molarity, but they didn't give you the moles, but they gave you the grams, and that's okay because we can always get the grams if you have the mass and the molecular weight. All right. So I think that's enough about the molarity. We're going to use the molarity a lot. I'm talking about a lot. So make sure that you practice. You should have plenty of practice material to do that. All right, so let's talk about molality. with the big L. This one is weird. We don't use this as much. It's the less common one, and we symbolize it with M, small m. And some people confuse it with the mass, but no, this is the molality, right? And this uses the moles of solvent over moles of solute over kilograms of solvent. So you're still using the moles of solute at the top, but at the bottom, instead of using the solution, we're using the solvent. And instead of liters, we're using the kilograms. And you might ask, why do we need this? Well, it's because there are things that we need to measure that don't make sense using liters. We use kilograms. So every one of these concentration measurements that we have was created because of a purpose, because the other ones were not good enough to give an accurate measurement. So that's the number 6. That's the formula number 6 of concentration measurements. So we have weight by weight, weight per volume percent, weight by weight percent, parts per thousand, parts per million, molarity, and molality. And you should be able to calculate, convert, and move these around so that you can, calculate concentrations. Or you may be given the concentration and you calculate one of the terms in the formula. I'm going to provide more practice materials, but you should know now how to use these formulas. And I'll see you next time.